Hi everybody. Today we are solving a problem from the first chapter. Here we placed two charges, minus Q0 and then minus 3Q0, two negative charges which have different values, and then they are separated by a distance L. And then the question is that if we place a charge in the middle somewhere, or anywhere else, okay, outside or inside, let's say plus Q there, okay, right in the middle somewhere, the distance measured from the left charge will be X, so that X equals 0 there, okay. So is it possible that these two charges will be stationary after this is placed? Oh, of course, if these two charges are stationary, then this charge will be also stationary. So find what is the X value as a function of L, of course, as a function of L, what X value the system, at what X value the system is in stationary position. And also, what is the value of charge in terms of Q0 for stationary or equilibrium situation. So now let's concentrate on this charge A. This is B. Okay, if you look at charge A, okay, we have negative Q there, minus Q0, okay. Now, we have, because this is plus Q and this is minus 3Q there, and this is minus Q0, so plus, okay, draws this, okay, attracts, so that the force due to this one will be there. So this is F1, let's say, F1 to the right, because of this. And then F2 will be this way because minus pushes minus, okay? So F2 will be due to this minus 3Q. So if we write this, we have to know the distances between the two. As you see, the distance between the two is X, but the distance between the minus 3Q and Q is just L, okay? So basically, F1 and F2 are readily written, okay? F1 will be just the force due to this one, don't forget. So K times Q0 divided by the distance square, X squared. But F2 will be just the force between the two, so that K Q0 times 3Q0 divided by the distance squared, the distance is just that. So in order the system, or in order the charge at point A to be in equilibrium, okay, what we have to do is just let these two forces be equal to each other. So F1 equals F2. So they must be equal to each other. If they are equal to each other, as you see, K's will cancel, one of the Q0s will cancel, and then we have an equation given by Q over X squared is equal to 3Q0 over L squared. So if you rearrange this equation, we get L squared Q, which is equal to 3X squared, okay, Q0. So this is the first equation we obtained. As you see, this is an equation, X as a function of L, okay, but now because we need two unknowns, X and Q. Here, this is unknown, and this is another unknown. We need one more equation. How do we do this? We have to, now we consider this charge also. Now, as you see, let's now give some names, okay? So, to these forces. Okay, so this plus attracts this one, so that this is this way, so F3, and then minus pushes minus, F4. F4 is due to these Q0 and 3Q0, but F3 is due to 3Q and Q. But we have to really consider the distance between these two charges. Guess what? It's just L minus X, okay? If you know the distances L and X, this is just the difference between the two. Okay, now we are setting now F3 to F4. Let's write F3 first. F3 will be equal to, don't forget, this is the attraction force between the two, and the distance is L minus X. So K, Q, 3Q0, this is 3Q0 divided by the distance L minus X squared. Okay, F4 is now the force between the two negative charges. Okay, so it's K times Q0 times 3Q0. The numbers are usually written in the front, but I'm writing it like that to show you that this is the product between the two charges, and the values of the charges are given like that. Divided by the distance square, but the distance between the two charges is just L, as you see. This is just L square. So they must be equal to each other. So if F3 is equal to F4, and as you see, when they are equal to each other, then K's will cancel, and then one of the Q0s will cancel again, and then there is 3 which are also being cancelled. So in this case, what we end up with is this equation. For this one, we get L square Q is equal to L minus X squared times Q0. Okay, this is it. This is the second equation. So now, as you see, we have two equations and two unknowns that we can solve. Now, if they are both equal to L squared, they must be equal to each other, so that 3x squared Q0 will be equal to L minus X squared Q0, and then Q0s will cancel. And then if you open this up as L squared minus 2LX plus X squared and put everything to the left-hand side, this is exactly what we end up with, okay? 2x squared plus 2LX minus L squared, which is equal to 0. Because if this is put to the left-hand side, there is 0 on the right-hand side. So we have to solve this second-order parabolic equation, which will give us two solutions, okay? 1 and 2. Two roots of this thing. So if the parabolic equation is given by ax squared plus bx plus c equals 0, we know that the roots are given as, okay, minus b plus and minus square root of b squared minus 4ac divided by 2a. This is something that I remembered from high school, and I keep using over and over again. So please try to memorize this thing, because many times in your education you will come across with this equation, and this is the root. But in our case now, a equals 2, b equals 2l, not the number only, as you see, and then c is just minus l squared. If you put everything here, okay, this is what you get. This you will get now x12 will be given as minus L over 2 plus and minus, okay, 2L square root of 3 divided by 4. How did we end up with square root of 3? Because this square root gave me this, okay, 4L squared plus 4AC minus 4AC. So A is 2, but C is L squared with a minus sign, so that minus plus. And then now I end up with 8L squared. So now if I factor out 4L squared, it's just 1 here, and then plus 2 there. And then this gave it 3, and 4L squared went outside the square root sign, and this is really what I end up with. So basically, if square root of 3 is given as like 1.73 or something, we find two roots. One of them is just 0.366 L. As you see, x is a function of L, and x2 is minus 1.37 L. Okay, so there are two solutions. Maybe both of them are correct, or maybe just one of them is correct. So guess what? Only this is correct. Why? Let me explain you why this cannot be correct. Because now look at it here. Look at here. So remember that this is minus Q0 and this is minus 3Q0. If I put this plus charge here somewhere, let's say this is plus Q, do you know what? Let's look at this case now. So this plus attracts this minus, so that the force will be to the left between the two, okay? But for this one, okay, so minus will push the minus, and then it's, as you see, this is just not attraction, but repulsive force, so that these two will push each other. So basically the force due to 3 minus 3Q0 will be also in this direction. There is no way that these two forces will be able to cancel each other in this, because they are all in the left direction. So this is impossible. So remember, this is x equals 0, this is minus value. So this is not accepted. As you see, mathematics gave us this solution, but physics allowed us to choose one of the correct solutions. So X should be 0.366 L in order the system to be in equilibrium. So how can we solve Q as a function of the other Q? By using one of the equations. For instance, we can use this one, so that L squared times Q will be equal to 3x squared, but X is 0.366 squared, times L, times Q0, because 3x squared times Q0. And then if you put all these values, L squared Q will be this, 3x squared, but L is also given, so as a function of L, because this is 0.366 L squared, so L squared will cancel, and then Q will be given as 0.402 Q0. So in order the system to be in stationary position, not only X1 should be 0.366 L, but also the charge amount should be less than the half of Q0. Only then the system will be in equilibrium. This is the solution. End of recording.